Alright, hell yeah. We got statics for straight up G's. I mean engineers. Alright, here we go. So we got problem 7. Now you can refer to problem 1.6 because I just did it. You know what I mean? At the end of problem 1.6, I was just like, oh, hell yeah. This totally leads into finding the spring constant is K and finding the units for the spring constant. And so we'll just start by doing F equals MA. Because this problem says, hey, you got to use the MLT system. Sometimes when I'm hungry, I use the BLT system. But anyway, and the other system is the FLT. You know what I mean? And so let's go over those two right now, because that's actually the most important part of this. I mean, at the end of the day, oh yeah, because it just switches the problem around. Because had you done this, hey, force is in Newton, so you have F equals the spring constant and then X. This is a distance, this is a force, so we just did this in the last problem. So you have newtons here, K, and then you have meters. You know what I mean? So what should this be? Two ways to do it would be like, hey, you need a Newton, so K has to have newtons. You know what I mean? But you don't need a meter. So we're going to divide by meters so those cancel. So now we have K is Newton meters. That's the units on K. But what they want is say, hey, we're going to use the MLT. This is mass. This stands for mass, length, time. And it don't know what a force is. You know what I mean? And then the FLT system is force, length, time. It don't know what a mass is. You know what I mean? So anytime a problem says use these two systems, I would do this. I would write F equals MA. And then I would write newtons, kilogram, meter per second squared. There you go. And this is what a newton is, and then I would solve for kilogram, just so you have both these, because a kilogram is a newton divided by meters per second squared, which is going to be meters second squared divided by newtons times second squared divided by meters. So there you go. So this is going to be very useful. And because the other thing that you could do is you could say that F equals MA. You could say that this is a force, this is a mass, and this is a length divided by time squared. You know what I mean? So this is kind of what they want you to do. And I think it is a little bit wonky because I'm used to M being for meters, and then, you know what I mean? But in this situation, M is for mass. Length is meters, time is second squared. But you have force, so you have F, M, L, T squared. But in both these systems, you can only have one or the other. So this says, hey, if you're using the MLT system, every time you see a force, so we see a force right here, you have to substitute in MLT squared. So let's do that. So we have a force, so we have our equation, F equals spring constant X. We see a force because we're using the MLT system. So we have to, we write our F equals MA. And then we say, hey, this is force equals mass LT squared. And then so we solve for force. Now, same thing, just like we did this, we can solve for mass. So we can go mass is equal to force times squared divided by length. And then these are your two equations. You know what I mean? They won't let you have both. And at the end we'll do Kepler. But anyway, let's solve this one. So we're gonna, for F, we're gonna type that in. MLT squared. See, at this point, I'm just typing in letters. There's no way my mind can handle, you know what I mean? I don't like the MLT and the FLT system. I just say, hey, just use the SI units or the US customary units because it'll just make more sense. Anytime that I see kilogram, meter per second squared, hell yeah, I know that's a Newton. You know what I mean? If I see ML over T squared, I have no idea, never in my life, besides first chapter, you know what I mean, problems, have I ever seen this. You know what I mean? So I have no connection between like, oh, I see that's a force. That's an F. because you know what I mean. Never. So we're just trying not to make any hiccups. So anyway, so F is equal to ml over t squared, and then we have our k, which we don't know, and then length is x is in length. Perfect. So now same thing. Two ways of doing this. You can either just isolate k. So but let's not do it that way first. So if we say, hey, we have to have an m over here, so k has to have an m. Okay, and then we need an L. There's already an L. Okay, so we don't. And then you have a divide by time squared over here. We have to have that. So we have to. So there you go. So that's k. If you throw this in for k, you'll get ml over t squared. That's exactly what that is. Booyah. The other way to do that is get to this part and then just solve for k. So we're going to go k is equal to this side, ml t squared, and then we're going to bring that downstairs. You know what I mean? Divide by L. L's cancel, and then we have k is equal to m t squared L. Sweet. Booyah. Booyah. And we did it. You know what I mean? And let's say FLT. You know what I mean? Hey, solve for k with the FLT. I think we just did it right there. Kinda. You know what I mean? So let's do that. So we have F is equal to kx. We're using the FLT. We just can't have anything that has mass. You know what I mean? So I'm just for force of gravity, gravitational constant, mass 1, mass 2, radius squared. Hey, I see a mass right there. We can't have it at the FLT. You have to, the units on this have to be in force, length, and time. But I know that a kilogram is equal to a meter, is equal to a Newton divided by a meter per second squared. You know what I mean? So you could convert all these kilograms to force, time squared divided by meter. You know what I mean? Or F time squared divided by L. You know what I mean? So this is force times squared divided by L squared. You know what I mean? And then that L squared, let's see. Divide by L squared is the same thing as multiply by 1 over L squared. Yeah, so now you'll get 4 L's. You'll get 2 forces, and you'll get, so you'll get force squared time to the 4th divided by length to the 4th. You know what I mean? You do you. If that's what you wanted, that's what you got right there. You know what I mean? And then we're going to do that in a second. So where were we on this? So we were using the FLT system to solve for this. Well, you already have an F over there. So you got F is equal to K and then an L right there. So it looks like K, well, you have to have an F, and then you don't need an L. So that's one way to do it. Or you can just isolate K. K is equal to F over L. Booyah, done and done. And if you did it the simple way with the FLT, then you can just say, hey, if I know by the FLT K is equal to F over L, now I can be like, hey, what's the MLT? So between the FLT and the MLT, you definitely want to write F equals MA. You know, however you do it. Write newtons, kilogram, meter per second squared, and then write kilograms is equal to newtons, seconds squared, meters. You know what I mean? And then just write out the force. Hey, this is a force, mass, length divided by time squared. This is a mass, force, time squared divided by length. And then here's your two equations that you can use, you know, interchangeably. So if it says, hey, you need the MLT, anything with an F, convert to MLT. So there you go. So K is equal to ML divided by T squared L. You know what I mean? L's cancel, and you got MT squared. Double check to make sure that's what we got, so we're not just losing our friggin' minds. But yeah, there you go. K is equal to M over T squared. This, you know, it's a kilogram second squared. I've never heard of that, but we know that kilograms are related to newtons, if you have meters per second squared. So there you go. This is F equals ma. So if I see a kilogram, hell yeah, I can go Newton seconds divided by meters, and then throw that in. So I see kilograms over time squared, so I'm going to throw in a Newton. Seconds will cancel. And then I'm going to get newtons divided by meters. And that's what we're familiar with. Spring constant is Newton divided by meters. In the last problem I said, hell yeah. The spring constant force is real cool because you get a spring constant K that's units are Newton meters. So it says, hell yeah. It's like if you give me the meters, guess what? I'm going to pump you out a Newton. I'm going to tell you what the force is. You know what I mean? So it's kind of cool that this works like that. And I compared it to density. Density is like in kilograms per meter cubed. Hey, you give me a volume, meters cubed, guess what I'm going to give you? Kind of the mass. I was going to say weight, but mass in kilograms, you know what I mean? And then, you know, this is pretty cool because we have gravitational constant, mass 1, mass 2, r squared. You know what I mean? So there's like a ton of different ways to do that. There's typically 3 ways you'll see this. You know what I mean? This is kilogram, this is kilogram, and this is meter squared. Well, and this is force in newtons. You know what I mean? So G, you have to have a Newton. So I like doing it this way. It's just like, what do you need over here? It's like a puzzle. Well, I need a Newton. What do we not need? We don't need any of the kilograms. So we're going to kilogram squared downstairs. We don't need any of the masses. We got to cancel that by throwing meters squared upstairs. Booyah. So this is the units that you'll see for gravitational constant. But if you use the FLT MLT method and then substitute these in, you know what I mean, which is the same thing as saying newtons is equal to kilograms meters second squared, and then kilograms is equal to newtons second squared meters, which we've done. So here's your kind of 2 equations that you would definitely just want to write and get anytime you do these MLT FLT problems. And so if I see a Newton, I can just throw this in. So if I do that, I'm going to get a kilogram upstairs. That's going to cancel a kilogram downstairs. And I'm going to have another meter upstairs. So I'm going to have meters cubed upstairs. And I'm going to have a seconds 2 downstairs. So there you go. Again, this is another way to do it. Now we can either get right to do it all in newtons. We can substitute kilograms into this one or this one. You know what I mean? You choose. You do you. You know what I mean? If we do it into this one, we're going to get a Newton downstairs. We're going to get seconds downstairs squared. So we're going to have seconds to the 4th. Oh, and then newtons downstairs. Newtons downstairs. Seconds to the 4th downstairs. Meters is divided by this goes to the top, so you're going to get meters to the 4th. So now we have meters to the 4th divided by newton seconds to the 4th. Another way, in U.S. customary units, you'll see this as feet to the 4th, pounds, seconds to the 4th. That's kind of how you'll see that. Now, I was just tripping out because it's just like, well, hell, there's 2 kilograms here and only 1 Newton there. So there's a third way to do this. You could just convert one of these kilograms to newtons. So let's do that. So we're just going to go one of them. So we're going to go Newton meters squared, keep one of the kilograms, and then the other one we're going to convert this. So we're going to go newtons seconds squared, meters up top. And this is going to kick us out. Newtons are going to cancel. And then this is going to kick us out meters cubed, kilograms, seconds squared. Oh, we already got that one. You know what I mean? So you're either going to have kilograms squared and a Newton, you're going to have a kilograms and no newtons, or you're going to have, I think that's it. Can you get a Newton squared? Maybe you can't. Maybe there's just these ways. That's all I'm seeing right now. And I was just thinking maybe there's just another way to do it, where you know what I mean, where you'd get Newton squared. I don't see it. So, but anyway, I think this gives you enough information to be like, oh hell yeah! If I see an FLT problem, you have to write this friggin' equation, because if you have FLT, you can't use M, and so anytime you see M, you got to substitute FT squared over L. You know what I mean? And vice versa. All right, hell yeah. Thanks for joining me, and guess what? That's a video.